Alright, so this question is stating a hydrogen atom is composed of a single electron and a single proton. Calculate the electrostatic force between them if they are 10 to the minus 15th meters apart. Calculate the electric field strength of the electron, and then if the mass of the electron is 9.11 times 10 to the minus 31 kilograms, calculate the orbital velocity. So let's start with question A. Question A. So basically what we have here is a positive charge here, a negative charge here, and they're orbiting their a distance of 10 to the minus 15th meters apart, and so it says calculate the electrostatic force. So the equation for electrostatic force, Fe equals K Q Q over R squared. In this case, K is always a constant. It is 9 times 10 to the 9th. And the units for that would be newtons per coulomb square meters, which is kind of weird, but we'll ignore the units for now. The charge of the proton is the elementary charge. It's 1.6 times 10 to the minus 19th coulombs. And that's also equal to the charge of the electron, too. It would be, they both would be the same value, except the electron would be negative. And then R would equal 1.0 times 10 to the minus 15th meters. Now that's squared, but basically you just plug these numbers into the equation and you'll get your force. Now, question B, calculate the electric field strength of the electron. Well, electric field strength, we can just symbol it as E, is defined as electric force divided by charge. It's basically how much force each charge is experiencing. Remember when we do those electric field lines like this? It's saying like how much force would something experience if you were to put it on that line. The way what you do is just you take the force that you calculated in question A and divide it by the charge of the electron, which is 1.6 times 10 to the minus 19th coulombs. And you got your electric field strength. Or you can calculate this force again and just put 1 in for one of the Q's. That would also get you the right answer. Finally, question C. If the mass of the electron is 9.11 times 10 to the minus 31 kilograms, calculate orbital velocity. Well, the way you calculate orbital velocity is that this electron is being pulled inward with this force right here, and that force, that electrostatic force, is providing a centripetal force on the electron. So basically, we have KQQ over R squared is going to equal mv squared over R. Now you can simplify this a little bit. Some of the R's cancel out. At least one of the R's cancels out. The mass of the electron is given in the problem, 9.11 times 10 to the 13. And you already solved for a lot of this already. What we're looking for is V. What is V? We're going to have a pretty big number for this, but overall it's not going to be too bad. So hopefully that helps with that question. Let me know if you have any other questions. I could post more videos about different